Hello everyone, this is Mr. H again and welcome back to my YouTube channel. In this video, you will learn about simplifying trigonometric expressions, which will involve applying different trigonometric identities. But before we jump straight into the very first example, let's take a look at some of the trigonometric identities that we will be using. So here are some of the trigonometric identities that we will be applying later when we answer a few examples. So we're going to start off with the reciprocal identities. Sine theta is equal to 1 divided by cosecant theta. So we have here cosecant theta equal to 1 divided by sine theta. So we have here tangent theta is equal to 1 divided by cotangent theta. Cosine theta equal to 1 divided by secant theta. We also have here, here's secant theta is equal to 1 divided by cosine theta. And cotangent theta is equal to 1 divided by tangent theta. So those are the reciprocal identities. All right, so we also have here the Pythagorean identities. So we have here cosine squared theta plus sine squared theta equals 1. Next is 1 plus tangent squared theta equals secant squared theta. And we have 1 plus cotangent squared theta equals cosecant squared theta. And the last group, we have the quotient identities. So we have tangent theta is equal to sine theta divided by cosine theta, and cotangent theta equals cosine theta divided by sine theta. So again, there are three different groups here. We have the Pythagorean identities. We also have reciprocal identities and quotient identities. So you really need to be familiar with all these identities, because when you simplify trigonometric expressions as well as verifying identities, so that will be discussed in a separate video. All right, so let's take a look at example number 1. Example 1, we need to simplify the given expression here. So we were given 1 minus cosine squared theta divided by tangent squared theta. All right, so aside from mastering the fundamental identities that we went over earlier, there are a couple of things that you also need to remember when simplifying trigonometric expressions. So if there are patterns that are recognizable in the given expression, like for example, an expression can be factorized, or if there's something that you can expand, or finding common denominators, or you can also apply different algebraic techniques to kind of manipulate the expression. You can always do that. Aside from recognizing patterns, you can also convert to sines or cosines, or sines and cosines if it's possible, like in this example. All right, so recalling one of the Pythagorean identities, sine squared theta plus cosine squared theta equals 1, right? And that's very obvious that this identity can be applied in the numerator. So the numerator can be rewritten as sine squared theta. So we can see here that the denominator is tangent squared theta, and tangent squared theta can be rewritten into sine squared theta divided by cosine squared theta. And then from here, we can simplify. So we copy the numerator, sine squared theta, and for the denominator, we get the reciprocal of that. The reciprocal of that is cosine squared theta divided by sine squared theta. And switch to multiplication. And then from here, you can see that the sine squared theta can be canceled out, or sine squared theta divided by sine squared theta is 1. Okay, so replace that by 1. And we are left with the final answer. So we have 1 times cosine squared theta is cosine squared theta. All right, and that is the answer. That is the simplified version of this original expression. All right, so let's take a look at example number 2. So we were given tangent theta minus secant squared theta divided by tangent theta. So like what I mentioned earlier, one of the things that you need to do is algebraic manipulation, right? So that can be applied here, because if we rewrite this original expression into a single fraction, this is going to be like this. So we multiply tangent theta to this one. So tangent theta times tangent theta is tangent squared theta. Then we copy minus secant squared theta. And then for the denominator, we simply copy tangent theta. And after doing that, we can see that the numerator is actually one of the Pythagorean identities, right? And tangent squared theta minus secant squared theta is actually equal to -1. And we simply copy the denominator, tangent theta. And you can see from here, this is reciprocal identity, right? Is equal to negative cotangent theta. And that is the answer. All right, so if you are enjoying the examples, give me a thumbs up. Or if you haven't subscribed yet to my YouTube channel, please do so by clicking subscribe and hit the notification bell so that you won't miss any of my future videos. All right, let's head on to example number 3. For example number 3, we need to simplify the expression to an expression involving a single trigonometric function with no fractions. All right, so we were given 1 plus cosecant t divided by 1 plus sine t. So by looking at the expression, we can see that cosecant t can be rewritten into 1 divided by sine t, which is one of the reciprocal identities, right? So we copy 1 plus cosecant t can be rewritten as 1 divided by sine t, and we copy the denominator, so 1 plus sine t. And the next thing we should do is rewrite the numerator into a single fraction. So what we can do is we multiply sine t times 1 is sine t plus 1 divided by sine t. That is for the numerator only. All right, so do not forget the denominator, which is 1 plus sine t. All right, and then from here we can proceed with dividing the entire fraction. We can do that by taking the numerator first. So we have sine t plus 1 divided by sine t. And then for the denominator, which is 1 plus sine t, we get the reciprocal of that. And from division, we switch to multiplication. All right, so if you take a look at this, And this one, we can divide that is equal to 1, right? Or we can just simply cancel that and replace it by 1. This 1 times 1 is 1, divided by sine t times 1 is sine t. Well, technically it's already fine, but because the instruction tells us that there shouldn't be any fraction, right? 1 divided by sine t is equal to cosecant t. And this is the final answer. All right, let's head on to our last example. Example number 4. So simplify the expression to an expression involving a single trigonometric function with no fraction. Same instructions as number 3. All right. So we were given secant theta minus cosine theta divided by sine theta. All right. So again, one of the things that we can do is to convert to sine or cosine. All right. And it's clear that secant theta can be rewritten into 1 divided by cosine theta because of reciprocal identity, right? Into 1 cosine theta. Then we copy minus cosine theta divided by sine theta. And for the numerator, we can rewrite this as 1 fraction. And we can do it by multiplying cosine theta times cosine theta. So cosine theta times cosine theta is cosine squared theta. And we copy the minus, and we copy 1. But don't forget the denominator, cosine theta. So that is the denominator for the fraction in the numerator. So do not forget to copy the original denominator, which was sine theta. And from here, we can proceed with the division process. First, we take the numerator. So 1 minus cosine squared theta divided by cosine theta. And we get the reciprocal of the denominator, reciprocal of sine theta. All right. And switch to multiplication. So if we take a look at this one, 1 minus cosine squared theta is one of the Pythagorean identities, right? So 1 minus cosine squared theta is actually equal to sine squared theta. So we can change that to sine squared theta. And from here you can see sine squared theta divided by sine theta. So we still have 1 sine theta left here. This is going to be changed to 1. All right. And proceeding with the multiplication, so we have sine theta times 1 is equal to sine theta divided by cosine theta times 1 is cosine theta. And as you can see here, sine theta divided by cosine theta is one of the quotient identities, right? And we learned that sine theta divided by cosine theta is equal to tangent theta. That is correct. So this is our answer. So if you learned something new from this video, please give me a thumbs up, share the video, and if you haven't subscribed yet to my YouTube channel, please do so. That is Math Hub by Mr. H. And don't forget to hit the notification bell so that you won't miss any of my future videos. All right, once again, thank you very much for staying until the end of this video, and I will see you in the next one.